This is the shaft sinking process flow. It's a cyclical process divided into segments which are generally consecutive. Drilling and blasting to mucking and bolting to concreting and back to drilling and blasting again. Under certain situations and specific conditions, the cycle can be sometimes needs to be short-circuited. For example, drilling and blasting to concreting, or concreting to mucking and bolting, or mucking and bolting to drilling and blasting, all depending on factors such as availability of suppliers, breakdowns or required maintenance of equipment, the lined height of the shaft at the time, the muck pile height at the bottom of the shaft, etc. Now, to schedule the shift, we go to the schedule input sheet and we clear the input cells. Now, the input cells are these light colored ones. The shift start parameters, the yellow ones along the top. The activity overrides, the blue ones down the left hand side, and the production override ones, the green ones on the right hand side. To clear the cells, we run the macro and we enter the shift start parameters. First, the date, the shift. We use the drop down list to choose day shift. We choose the hoistman via the drop down list. Same for the shift boss. And let's say that at the start of the shift, the unlined concrete height of the shaft was 13 meters and that the muck pile height was 6 meters. Let's also say that at the end of the previous shift, we were busy doing concreting, and we were part of the way finished doing the pouring the mains. So we use the start activity drop down list, select pour mains, and then we specify the number of units that still need to be completed, and let's say that's 3. Once the parameters are in, the system schedules the shaft sinking activities in this gray block over here, and this color bar indicates the segment of the cycle into which each activity falls. Like the yellow is for concreting, brown is for mucking and bolting, and red is for drilling and blasting. To the right of the activity list, the system shows us what the shaft will look like at the completion of each activity. The unlined height, the muck height, it tells us what the activity duration is, what the cumulative duration will be at the end of the activity, and what the activity start and end times will be. This block to the right of that shows us the production in units of measure. The column on the right hand side gives the units of measure: trucks, buckets, split sets, etc. The one on the left gives the total required units. The one to the right of the green bar or green column shows how many units will be produced in the coming shift, and the column to the right of that shows how many will be done in the subsequent shift. Now, if we look at the total required, let's see that all of the totals have been completed except for the last activity of the shift, which is muck cycle 3. We have 20 required, but we only do 7, and that's because the shift comes to an end, so the remaining 13 gets carried over to the next shift. The green column is the production override facility, and I'll explain that in a few minutes. This column over here converts the muck pile height into equivalent muck buckets, and the two columns on the right hand side identify workability and safety issues. If there are any, the issue will appear as a red message in this block over here. Before the schedule can be implemented, all of those issues need to be resolved. Right now we don't have any issues, so the schedule is good to go. Now, if we look at the schedule in this format, we see that we have a lot of information, much more information that is needed by those who have to perform the work. So we go to the short interval control, and that contains a much more user-friendly schedule. It has all the activities listed down the left-hand side, starting with the safety meeting and then the crew down, and it ends with the crew coming up just before the end of the shift. The control shows the plan. It lists the duration plans, it lists the plans for the start time plans, the planned units of measure, and the team is responsible for filling in the actual data as well at the completion of each activity. That enables them to determine what the variance is, and that in turn enables them to take real-time decisions and take corrective action when needed. All the variances are recorded under the delay code column over here, and each delay code has a meaning or stands for something. And if we look at the root cause analysis codes over here, we see drilling, loading, blasting, etc. So that gets entered, as well as the durations of the delays. This column over here, mucking cycle, is where the time at which each muck bucket goes to the surface is recorded, usually by the hoistman. Now, usually when you do a shift, we have more than just the shaft sinking activities. There are activities such as health and safety measures, maintenance, and so forth. So let's assume that during the course of the shift, we want to perform a maintenance activity. So we use the activity override drop down in the blue column, and we click on other, and we describe what that activity is, say maintenance, and the duration of it, let's say 1 hour. And as soon as you put that in, all the other activities below the maintenance activity shifts out by 1 hour. So we had at the bottom of our shift muck cycle 3, and that was 7 units scheduled, and when the maintenance came, that was shifted out, and it's only 1. And we can see that reflected on the short interval control. There's the maintenance activity for 1 hour, and the muck cycle 3 has been reduced to 1 bucket. Now, whenever you schedule the forthcoming shift, it's always a good idea to look further ahead by 2 or 3 shifts to identify issues, and that allows you to take earlier action, and that reduces the possibility of problems during the shift itself. So if we look down beyond the current shift that we're scheduling for, we see an issue over here, too little unlined height. And if we look across to the left, we see that the unlined height is only 1 meter, and it requires to be a minimum of 7. So we're not going to be able to do this concreting activity, and instead we need to insert a drilling and blasting segment of the cycle. So we use the drop down list in the activity overrides, and we insert drilling and blasting in the red over there. And if we look across to where the issues are listed, we see that the unlined issue has now been eliminated. However, muck on bench is now an issue, and if we look across to the left, we see that there's 1/2 meter of muck on the bench at the time that we should be drilling. So we might need to, or we will have to eliminate that prior to the drilling. So once again, we go to the activity overrides, and we insert an additional activity for mucking, and we click on mucking, and the system asks us to specify the volume of mucking, or the amount of mucking that needs to be done. So we look across to where the issue was raised, and to the left of it, it says 6.7 buckets. So we enter the 6.7 buckets, and as soon as we do that, the issue is eliminated. And if we go to the short interval control, we see we have inserted a mucking activity with 6.7, or rounded up to 7 units. Now, the supervisor might not want to have a separate mucking activity. He might just want to distribute the extra 6.7 buckets that are required across all the other mucking activities that have been scheduled for the shift. So you take out that mucking activity and look up each of the mucking activities, muck cycle 1, and increase that by, say, 2. Do the same for muck cycle 2, and then just before doing the third one, check to see how much is left. 2.7, so he has to add the 2.7 to muck cycle 3 and makes it 22.7. And as soon as he does that, the result is the same. The only difference is that the schedule is slightly different. So we don't have the mucking activity anymore, but muck cycle 1 and muck cycle 2 has been increased to accommodate the 6.7. Now, sometimes situations arise in a shift where we fall behind. There's some kind of disruption and we're unable to recover, and we have to update the schedule mid-shift. So let's say that during the course of the shift there's a breakdown, say, or interruption at about the time of the jack legs down, and that we're only able to be back up and running again and resume production around about 3 o'clock. So we use the blue macro to clear the cells, and we input the shift start parameters, or in this case the update parameters. Use the drop down to specify the day shift. Now, because we updating the schedule mid shift, we need to enter the time at which that happens, and we said that would be, say, 5 o'clock, or 3 o'clock should I say. We put that in, and we specify the hoistman and the shift boss as we did before. At the time of the breakdown or the disruption, the unlined height was 7 meters and the muck pile was 4.4. The breakdown happened shortly before the jack legs down activity, so we use the start activity drop down to find the jack legs down activity and click on it, and we hadn't started that activity yet, so we still have to do 100% of that activity. We enter that, and the system gives us a updated schedule over there. On the short interval control, we can see we're resuming production at 3 o'clock, and then in a short while, just before the end of the shift, the crew will go up to the top of the shaft again. Now, at the end of the shift, all the actuals that are captured on the short interval control is inputted into the production database, and that enables us to generate the production reports, the daily, the weekly, etc. Now, I'm not going to be talking about the reports right now. What I do want to talk about, however, is this analysis tool that's been built into the scheduling system. So we can analyze each activity in the shaft sinking process, and to do that we go to the yellow cell where there's a drop down list again, and let's say we want to look at drilling. So you click on drilling, and the drilling activity comes up, and it shows us the blue bars, the individual shift performances. The black broken line shows us the average shift performance, and the green line shows the standard. Now, if we look at the numbers, we see that the average is a little bit higher than the standard. If we look a little bit closer, we see there are a couple of activities where the variance is quite high. So if we could identify the root causes of those variances and eliminate them in future shifts, we'll be able to reduce the average, and that'll be closer to the standard. Let's look at another activity. Let's look at the muck to bench. So here we see that the average is 185 and the standard is 120. So that's quite a big difference. Here too we see there are a number of high variances, and once again, if we could eliminate those root causes, we will be able to lower the average, which will bring it closer to the standard. We might want to increase the standard to, say, somewhere 150. It's unlikely that we'll get it lower than that, because up to now we haven't yet been able to better the standard. Let's look at one more, and let's look at bolt screens 1. Now here we can see that the standard is very high. In fact, it's too high, so we will definitely need to reduce that. And the average is only 56, so we could reduce it to 56. But if we look a little bit closer, we see there are 2 or 3 shifts where there was a very high duration compared to the rest of the activity. So if we could see what caused the high duration in those shifts, we could reduce those and eliminate them from the future shifts, and that would in all probability bring the average to below what it currently is, maybe closer to 45 and 50. So the benefits of this analysis tool is, firstly, it helps maintain realistic standards for the tool, and if we're able to do that, then our schedules are likely to be more accurate and reliable. And secondly, it identifies opportunities for improvement. We identify activities where there are root causes which can be eliminated. We can reduce those, and thereby reduce the activity durations, and collectively reduce the overall project duration, which will increase the profitability of the project.